Good morning, dear students. How are you all? Fine. Okay. So this is the second video of class 11, and in this video we are going to see the chemical properties of alkenes. And here you can see that we are talking about the addition of hydroxyl group. And here, so addition of hydroxyl group we will see, and every time the addition of hydroxyl group will actually be over there when we will take the catalyst, and that one is KMnO4, potassium permanganate. Okay, now so it should be acidified, means some amount of H2SO4, concentrated H2SO4 you can add to make it acidic solution. So here you can see that if I will take this reaction, if I will take alkenes, and here the nascent oxygen would be there in the presence of water, it will actually react with one molecule of 1O, 2O, and this 2 hydrogen is there. So it can be written like this one, OH plus OH. Okay, now, and one OH as the symmetrical is there, so one OH will go at this position and one OH will go at this position. So ultimately what will you get? You will get this, the product you will get, and that one is the this case CH2OH, CH2OH. Okay, now you can see C2H4 plus nascent oxygen, and this one is hydration we are adding, so we will get this kind of product. So both are the same thing is there. Okay, this reaction and this reaction same is there. Okay, so this is used to test for the presence of C this double bond. Okay, now C double bond C. Okay, so we have seen that how the addition of hydroxyl group would be there. Now we will see the next one, and that one would be the halogenation. Halogenation is actually taking place in the presence of a catalyst, and that one is tetrachloromethane, that one is CCl4. And in the presence of CCl4, every time what will happen, that Br2 will add on both of the carbon atom, which is actually present between after the double bonds. You can see that one is at the left, one is at the right, and Br can be added. This can also be used to test for the unsaturation if anywhere present in the compound. If Br is there, that means bromine is there, that means bromine is a red orange color, and if you will add this red orange color into the unsaturated hydrocarbon, what will happen? After some times you will find that it will disappear, means bromine color will disappear. If it is doing so, that means we can say that bromine unsaturation, they have detected, bromine has detected that unsaturation is present into the organic compounds. Okay, now, and it will disappear its color. So this one is also a test to detect that saturation or unsaturation is present somewhere or not. Okay, wait. Okay, so in this video we are talking about the ozonolysis. That one is the chemical properties of alkenes. Okay, now, so here ozonolysis means the breakdown of ozone. Okay, now, breakdown of ozone, ozonolysis, ozone plus lysis means break down. Okay, now, break down. So here we can see that how can we break down the ozone molecule. You know the formula is O3. Okay, now, so first of all, if I will take some of the alkenes, and you know the double bond would be double bonded carbon atom would be there in the alkenes. So I will add this alkene, and then it will form the ozonide, one of the structure, that one is ozonide, and then ozonide in the presence of zinc plus H2O, zinc and H2O, that will actually dissociate, that will break that bonding of ozonide, and it will form some molecule of aldehyde. So we can see the reaction, and here we are going to take one reaction, that one is CH3 CH double bond CH2. This one is the propene, where I have taken propene, one example of propene, and I have reacted it with one molecule of ozone. What will happen? This ozone will form one of the ozonide. Ozonide is a ring type structure, and here this ozone will actually form a ring. Okay, now, cyclopropane type ring it will form. So how it will form? It will form, look, see, CH3 CH double bond will break down. Okay, now whenever some addition would be there, every time double bond will actually allow to react with this one, so it will form one of the structure, one of the ring structure. So you can see I will form ozonide, this one here, CH double bond I will break down completely, CH. Okay, now this will link with this one, and here one oxygen is this. Okay, now this type of structure you will get around the double bond. Double bond I have completely broken, and now you can see the bond will satisfied also. Here carbon 1 2 3, so I will add one more hydrogen. Here you can see this, for this carbon 1 2 3 4, oxygen 2 oxygen 2 oxygen 2, everything is balanced. So this structure is ozonide, and this one is propene ozonide. This one is propene ozonide. And now propene ozonide is actually take the help of zinc, a smaller amount of zinc would be there, and then this zinc will dissociate this, break the bond of carbon and oxygen, and it will remove zinc oxide. And what will happen? Now you can see the breaking, how the breaking will be there. One oxygen will lose with zinc, so how will be the breaking? This one you have to break like this one. Ozonolysis means breakdown of ozone molecule. I have taken this molecule out and this molecule out. So what will be the product? It will give the product like this one, CH3 CH. This oxygen I will not count because it has already loosened up. So CH3 CHO, CH3 CHO plus, here CH2O can also be written like this one. CH2O can also be written like this one, HCHO. Okay, na? CH2O. So this one is the ozonolysis product. Here you have seen that CH3CHO, one oxygen has loose, and I will break like this manner. Ozonolysis means breakdown. CH, equal number of oxygen, equal number of oxygen will go with this one. So HCHO and CH3CHO. As I have told that aldehyde molecule it will form. Okay, now so this one is the ozonolysis. We will see one more example for this one. One more example we will see, and here you can see that I will take the example of 2-methyl propene. So 2-methyl propene can be written like this one. Sorry, CH3 double bond. Okay, CH2 plus O3. How can I add? Same thing will be there. CH3 double bond will break down. This oxygen will be added on this one. Double bond will break completely. So one oxygen will add here with this one, CH2, and one oxygen will add with this one. Again, now I will add ZnH2O. Then what will happen? Zinc oxide will be loosened up. What will happen? This oxygen will lose with the Zn. Now we can do the breaking. Okay, now, and this one also. So you can see CH3 CO. But CO, so in this case you can see that CO is only there. That means aldehyde will not form. So you have to see and you have to focus this one. That if I have told that aldehyde it will form, that means there must be the availability of carbon, hydrogen and oxygen. But here you can see that only oxygen is there, no hydrogen is there. So what it will form? It will form CH3, or instead of this one you can write CH3. Okay, now then then it will react with oxygen, so double bond it will form with oxygen. Now plus CH2O. How can we write the CH2O? CH2O. This one is formaldehyde. Means ketone can also be formed and aldehyde can also be formed. But in the first reaction, first example, I had seen that only it has formed the two molecules of aldehyde. One was formaldehyde and one was CH3CHO, I think, ethanol. So this one is the major product. You can form the ketone also and you can form the aldehyde also. So this one is the ozonolysis, means breakdown of ozone molecule okay, to form ozonide, and after that ozonide it will react with ZnH2O, and you know that ZnO will be loosened up by this one, and it will form the ketone and the aldehyde. It depends upon you that, it depends upon not you, you can see that availability of hydrogen is there or not. If not availability of hydrogen, then ketone, otherwise if the availability of hydrogen is there, then aldehyde. Okay now, thank you.